so here we go, guys. Inverse variation. We're beginning chapter 4, inverse variation. And inverse variation is a way for us to compare numbers. So how the numbers relate to each other. And so let's first talk about some rectangles. The two rectangles shown both have an area of 144. 2 times 72 units squared. You guys want to use your Chromebooks?
I'm missing that.
You know what, class, hold on a second. I have to press pause. The website. Okay. Then the area of this rectangle is 6 times 24, which is also 144 units squared. Okay. The question asks, we're not going to sketch. I just want you to write down as many rectangles as you can that have the same area, which means that I need to find other rectangles that are 144. So I just care about the length times the width. Obviously, this is my length, super long. This is my width, okay? Think, brainstorm for a second, all the other ones that are 144. So give me some ideas. What makes 144? Well, 2 times 72, 6 times 24. Give me some more. 144, yeah. No, 12 would make a square. I want a rectangle. What else? Guy. 3 times 48. That makes 144. Go through the numbers under 10, you guys. Well, then some of them are above 10. Angela.
3 by 36.
3, no, because it's 3 times 48. I want 144.
18.
You already helped me. Say it again.
18 times 8.
8 times 18. Good job. 4 goes into it. Angela.
It was 4 by 36.
Okay, perfect. Great job. Okay, tell me more. Oh, you guys, can you imagine? It's true, he's right. 1 times 144, super skinny, but so long. Anything between 4 and 8 go into it.
6 times 24.
Yeah, 6 times 24. Anything above 8?
9 times 16.
9 times, yes. Good thinking, 9 times 16.
Twelve times 12.
That'd be a square. We want a rectangle. This is done. We're done, guys. Okay, so this is good. Those would be equal to 144. I'm going to scroll up. Oh, considering rectangles, real quick, let's just do B. What happens to the value what happens to the width as the length increases? As my rectangle gets longer, what's the width doing? As my rectangle gets super long, what's happening to how wide it is or how tall it is? It's getting skinnier. As the width, whoa. As the length increases, the width decreases. As one thing goes up, the other goes down. And that is inverse variation. So one thing goes up, one thing goes down. Here we go. Inverse variation. It's a relation between two variables such that as one variable increases, the other decreases proportionally. So if my one variable is going up by 3, by a scale factor of 3, and it's consistent, then the other variable goes down by like a scale factor of 2 or a factor of 2, and it's consistent, then that would be inverse variation. It can be anything. It doesn't have to be the same number. Okay? All right, good. Here's my formula. K, wait. This variation is modeled by y equals k over x. K is my constant. My constant stays K. Sometimes I'll be asked, like once I find out what K is, to use that, but I always put a K in my inverse variation equation, and it's the y and the x that gets substituted in. So I've got this. And if let me get a blue so I can show you. In the case that I wanted to solve for K, I'd have to get rid of X. So I'm going to get K alone. I got to get rid of X. So I'm just going to, since it's K divided by X, I'm going to multiply by X on both sides. K equals X times Y. Both of these represent inverse variation. Y equals K divided by X, K equals XY. All right? So we're going to use these today to help us solve problems. This is inverse variation. Oh, K is called the constant. Okay. Direct variation. Direct variation is how two things in life relate to each other, like the health of my body is directly related to how much I exercise. Okay? The amount, this is a good one for you guys who love your cell phones. The amount of time I spend looking at my cell phone like this relates directly to the fact that I'll grow up to be a hunchback. Be careful. Put your shoulders back, stand up straight. Even if you're looking at your cell phone, you don't want to roll your shoulders and become a hunchback. That is all on that. Don't be a hunchback. So now the variation on direct is one variable increases and the other increases, and they increase at a proportional rate. The variation of this is y equals kx. There's no division problem. There's not k over x. They're directly related to each other. So this is direct. Okay? If I were to solve for k, I would get y over x. Are you guys all sitting up straight in your rooms now? Being over paranoid about being a hunchback? It'd be cool to be the hunchback of Notre Dame, but then it wouldn't, you know? All right, so let's talk about the patterns that we see in the table. Does the table of values represent an inverse variation? So here's what I've got. X, 1, 2, 3, 4, 6, 12, increasing, right? Y, decreasing, 12, 6, 4, 3, 2, 1. Is this inverse variation? Is one increasing and one decreasing?
Yes.
Yeah.
Someone in Zoom, because I have heard from most of the kids in my class. Someone in Zoom.
Yeah.
Yes. Yes, inverse variation, woo! Okay. Let's look at the second table of values, my input. Don't forget all the words you've learned. Input domain for X, output range for Y. All the things that we've ever talked about in algebra are still relevant. 1, 2, 3, 4, 5, 6. Increasing. Y, 20, 17, 14, 11, 8, 5, decrease, 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 decrease. All right. Is this inverse variation? Class in here. Yes, they're all nodding their heads in case you guys are wondering. You guys got to come to school. It's awesome. Cool. X values, 6.6, 5.5, 4.4, 3.3, 2.2, 1.1. Decrease. Huh. But my Y, 3, 5, 7, 9, 11. Increase. Now, I never said that it always had to be the X always increases and the Y always increases. If you look back up at the definition, it says one variable increases, one decreases. Doesn't matter which one. This is still, yes, inverse variation, table of values 3. Sorry about all these. Okay, the question below, real quick, I can answer. What does it mean if the product of X, Y is not constant? Okay, like, if there's no consistency, if it's not constant, then what? Because this is like the definition of inverse variation. If the, like, because it's on inverse variation, I can also say like K, the constant is X times Y. If they're not constant, then the table doesn't represent inverse variation. Okay.
Miss Grant,
Yeah.
how would the first table be constant? Because it goes like it goes up by 1 and then skips and it goes by 2 and then 6.
Because what we're looking at, I want to talk about this one right here, because what we're looking at is we're looking at the values of X and Y. If they have the same 12, 12, 12, 12, 12, 12. This one, let's change it because I just noticed the constants don't multiply the same. Okay. And to be honest, the third one then, wait, hold on. I got to do a little bit of work. Hold on. Okay, one increases and the other decreases, but the constant isn't the same when I multiply on here. Yes, it is inverse variation, but the K isn't constant. So the next problem that we're going to do is going to look at the table of values and how they have to, the X and the Y have to multiply to be the same number. I'll go to the next page and the next problem is like perfect for it. All right. There we go. Give me a second to erase. So now I'm looking. John draws 5 rectangles in which X represents the length and Y represents the width. What are the areas of his rectangle? Okay, first of all, 1/2, 1, 3, 5, 12 is increasing. So we check that first, just like we did on the last problems. 15, 7.5, 2.5, 1/2, 5/8, that's decreasing. So far, so good. Now we need to check the constant. Right? Does the constant have the same, because it has to go proportionally.
Sorry, I was just checking the grade.
Well, good, you can later. So in your backpack. All right. So I need some people at home, if you have a calculator, because like the last few ones might not be as easy. But half of 15, multiply X times Y, guys. Half times 15. Half of 15.
Constant.
But it's what? I mean, I need the value.
Oh,
7.5.
Thank you. 7.5 times 1. Same. Whoa. I don't know what that is. All right, decimals and fractions. Change it up. Doesn't matter. 3, 2.5. So 2.5, 2.5, 2.5. $2.50 plus $2.50 plus $2.50. 7.5. I'm just playing by writing them differently. It doesn't matter. 5 times 1, and then 5 times 1/2. 5 times 1/2 is 2.5. So 5 plus 2.5. You can do this math in your head. Just a quick verification. 5/8 times 12.
7.5.
Yeah. So yes, the constant is the same. Okay, so that's an example of when we would check it to make sure. So here we go with these next 2 problems. We're going to put this into use, all right? I want you to remember the following. Y equals K over X. In an inverse variation, X equals 10 when Y equals 3. So I'm going to actually plug in. Instead of X, I'm going to put a 10. Instead of Y, I'm going to put a 3. And the K is that. So I'm replacing the values with what I was given. I'm going to solve for K. That is simply the denominator needs to be canceled out. 10 times 3 is 30. So I'm good, got it. I found my constant. Write an equation. Now I'm doing something, write an equation to represent the inverse variation. That's this. Then, here's my then. Find the value of Y. So I want everything to be clean. Okay, now it's asking me to use my K in a circumstance. Find the value of Y. What is Y going to be when X equals -6? What's Y going to be when X equals -6? Well, the K is missing. In this case, since now I'm being asked, it's like an extension problem. Now do the next step. I've just figured out my K is 30. So I'm going to use my K, because otherwise I can't solve this problem at all. 30 divided by -6. My Y value, in this case, find the value of Y. My Y value would be -5. I found my constant. And then I was asked a next question. Okay, well, what is Y if I know that X is -6? So then I used my K. I put my K into practice. Same thing with this next one. Oh, see, that's nice. Look at this waiting room. Love that. In an inverse variation, x equals 3/5 when y equals 1/6. Woo! Y equals 1/6. X equals 3/5. Do you recall how to do this? You might not have ever learned from your Algebra 1 teacher, you may have. I have a fraction in my denominator. That's no good. I can't have fractions in my denominator. So the problem is that I need to get rid of 3/5 down there. How would I get rid of a fraction? How would I get rid of that?
Multiplying it by its inverse. By the
Yeah,
number.
I'm going to use the word reciprocal. So multiply the whole, like the whole bottom denominator is 3/5. Whatever you do to one side, you do to another. The denominator is canceled out, the whole thing. I know that it was a fraction. It might as well just been a number. I do the same process. So K, 3/5 times 1/6. Multiply straight across, right?
I have a question.
Yeah.
Why didn't you multiply it by its reciprocal though? It was
I know, I
3/5.
just said that. Because I think that it's easier. I was thinking about that, but it's way easier. See how right here, whatever's on the bottom, you multiply the whole thing by that. It's a much quicker process when I do it this way. So I wanted to do it this way. But you'll see, I'm gonna do the reciprocal next. So I think that this is faster. This could say 58,000, whatever, and this could say 50,000, but I still would be able to cross them out if I multiplied the denominator by the whole number that it is. Here, doesn't matter what it says, if I multiply by that, it cancels. This is then 3/30, which we know is 1/10. That's my constant. Now I'm going to show you an example, you guys, because it says, then find the value of y. Okay, here's what I got. In this example, I don't know what y is, but I know that x is 2/5. And I know that k is 1/10. Now, I need to talk to you about this. This time, I am not going to multiply just by a giant 2/5 and a giant 2/5, like I did right there. This time, I'm actually going to use the reciprocal method because the reciprocal method right now is more effective and it's more efficient. I want y to stay alone. And if I was trying to keep y alone, then that means I need to just work on this side only. That's when the reciprocal comes in. 5/2, 5/2. Okay, this is a really good difference to make sure you know. And it's all about which is going to be the quickest for me and the most effective. That means my denominator, 5, 5, 2, 2, cancels. Multiply 1/10 times 5/2. 5/20. Did you get 1/4? Yeah. Okay, this is good to know the difference between. Write it down. I only have 5 minutes left, so I need to do at least the guitar problem. Evidence of thinking. Can I find an unknown value of x or y without finding k first? No, I have to know what k is. So no, you need to find k first. The next problem involves a real life scenario. On a guitar, the string length S, I'm gonna ask you, how do you know where the S goes? And how do you know where the F goes? So let's read the sentence. The string length varies inversely. That means inversely, F is at the bottom. String length was written first in the math problem. So string length varies inversely as, so inverse F goes on the denominator. K always goes on the numerator. Here we go. Now I'm going to actually do a problem. They're going to give me information. The frequency of a 26-inch string, 26. So the frequency is 329.63. We do this the same way. Multiply the whole right and the whole left to cancel out 329.63. And I'll just tell you, because it's easier that way. 8,570.38 is K. It's the exact same process that I just did on the two problems above, right? So now, that's my constant. Here's my next question. What is the frequency when the string is 13? If my string length is 13, what is the frequency? String length is 13. What's my frequency? Can I solve for one of the unknowns without the constant? No. But the constant, 8,570.38. Here's a trick. I do not want you to multiply both sides by F and then divide by 13. Here's the shortcut. When you're given a situation like this, when there's an unknown in the denominator, you are able to just flip, and we're going to divide by 13. Divided by 13. On the calculator, it's 659.26 cycles per, I'm solving for the frequency, second. Oh, sorry. 659.26 cycles per second. Okay.
Miss Grant?
Yep.
Wait, so you switched F in the denominator, but then, oh, never mind.
Because it asked me, what's the frequency? It didn't ask me what's the string length.
No, I was asking, I thought the,
Yes, this is totally legal in math. You can do it. Okay, guys, the bell's gonna ring. The bell's gonna ring. Your homework's on Pearson. So I need you
I
to,
didn't see that.
it's fine. Get that done. And then you can leave the Zoom meeting. I'll stop the recording. Kids in class, keep your name card with yourself and just bring it